Hello again. In the previous lecture, we understood what are the shortcomings of MapReduce. Now that we understood why Spark came into existence, that is because of the shortcomings of the MapReduce, which was the programming model for distributed processing. Now let us try to understand what are the advantages of Spark, which really made a difference and which made this tool really popular as compared to MapReduce. Because in most of the implementations in the recent past, we are preferring Spark over MapReduce. Let's see them one by one. One of the very important thing is Spark is a expressive programming model. What do we mean by that? Means as compared to the MapReduce, Spark is an expressive programming model. If you remember in the previous lecture, we said MapReduce only supports map and reduce based computations. Means everything need to be visualized as a map and reduce based computations. Anything you do in a data analysis and data engineering, we need to visualize and implement that as MapReduce based computations. On the other hand, Spark is expressive programming. Means very intuitively you can choose the operation or transformations which can be pipelined together to implement any data analytics tasks. It has almost 20 plus operations. Obviously, since Spark is a computing model for computing engine or a programming model for distributed processing, all these operations are distributed operations. Since it is an expressive programming language with more than 20 operations, we can string them together to accomplish any big data analytics task. That is one of the very important advantage of Spark. The second aspect is we call Spark is an in-memory processing programming model or a computing engine. Why is that? Don't you think MapReduce is also doing the processing in the memory? Yes, you are right. Any processing need to be done in memory. But why specifically we are calling Spark as a in-memory? Because if you remember, in the MapReduce, whenever we have to do a big task, that big task will have multiple intermediate steps and also multiple intermediate results. In MapReduce, whenever intermediate results are computed, they would be written back to the disk and they were read from the disk. Lot of time was spent there. On the other hand, in case of Spark, it will try to hold intermediate results or outputs of the iterations as much as possible in the memory. For example, let us say we are reading something from the disk, a data file or something in the disk, and we are applying some analysis or a computation here by using a Spark or Spark operations. That would be retained in the memory and that will be immediately fed to the iteration 2. Then it will be again retained in the memory as much as possible. Then we would be writing that back to the disk. Spark will try in all possible ways until the final result is produced to retain the intermediate results in the memory rather than writing it back to the disk. That is saving lot of time. And also it is easy to read the intermediate results when they are in memory. It will save lot of time also. Spark is known for in-memory processing. Because of this, the speed at which the Spark can do the analysis and complete the computations would be much faster than the MapReduce. Moving on, one of the very important aspect is, as we know, MapReduce is famous for batch processing. Spark definitely does the batch processing, but looking at the need of the hour, even Spark supports the stream processing as well. So that way is added advantage because it can do batch processing also, it can do stream processing also. Wherever, whichever the project needs the batch processing, we can use the Spark. whichever the project needs a stream processing, we can use the Spark. If any project needs both batch processing and stream processing, we'll be able to use the Spark itself. No need to go out of Spark for any of the data analytical or data engineering tasks. Next important aspect is, as we know, MapReduce was not having any interactive shell. On the other hand, Spark does have an interactive shell for each of its language APIs, for PySpark, for Scala, for SQL also. That makes it very easy for to practice, to try, and also to compute some other things. That is an added advantage for any programming model or a platform to have an interactive shell. Next, very important aspect is, as we understood, MapReduce supports only Java. On the other hand, Spark has 5 language APIs. Spark supports Scala, which is a hybrid programming language. It supports Java, which is very old programming language, which is there in the existence for almost 25 years now. Python programming language, which is a most ubiquitous programming language, whether it is a data science or a data engineering, Python is there. SQL, as you know, it is most loved by most of the data analysts or the guys who are working with the data. R, which is a programming language which has a wonderful statistical analysis packages, and it is very, very widely used in most of the academic institutions. Spark gives the language APIs for all these 5 important programming languages. To summarize, Spark has a expressive 20 plus distributed operations. Then Spark does a in-memory processing, and it supports the batch processing and also stream processing. It does has an interactive shell, and it has a 5 language APIs through which we can work on Spark. That makes Spark wonderful, powerful tool. Let us try to understand what is Spark in the upcoming lectures. Thank you.